Hello everybody, this is Mrs. Dubois, and today we're going to talk about graphing a systems of equations using decimals. A systems of equations is two equations with two of the same variables. So let's go back for a second, and we've seen in the past lines, all right, and a solution to a linear equation is an ordered pair that makes the equation true. If I want to do it algebraically, I will plug in. So for example 1, I have 2x plus 5y equals 9. Is 2, 1 a solution? To check it out, I'm going to plug in, this is my x and that's my y. 2 times 2 times 5 times 1, and make sure it does equal 9. Now I follow the orders of operations. 4 plus 5 equals 9. 9, in fact, does equal 9. So algebraically, I can tell that the ordered pair 2, 1 is a solution for the linear equation 2x plus 5y equals 9. Another way, and the way that's going to be our focus today, is to solve it by plotting it on decimals. And in decimals, you can put it exactly as it is, 2x plus 5y equals 9. And then you can see that the ordered pair 2, 1 does in fact fall on this line. So yes, it is a solution because it's a point on that line. Now, let's go back to graphing by hand, okay? We're going to start out with y equals 3x minus 1. The input are going to be our x's, and the output is the answer, or our y's. So in order to solve this, we're going to plug in. Start with the equation. So when x is equal to 0, what is the answer, or what is y? It's negative 1. So this is negative 1. Then we're going to plug in 1 for x. And we're going to get it 2. And then we're going to plug in 2. And we're going to get 5. 6 minus 1 is 5. All right, now I have my input, which is x, and my output, which is y. Now I'm going to write it as an ordered pair. And 2, 5, okay? Now I'm going to go over to the graph and plot this point. 0, negative 1, 1, 2, and 2, 1, 2, 3, 4, 5. Now if all your dots are in the right spot, this should form a straight line or a linear equation. Okay, let's try this for a few examples, all right? Okay, for each of the equations, complete the tables and find the ordered pair that they have in common, then circle it. We have started the first one for you, okay? Again, x is the input and y is the output or the answer. We'll proceed to the equation y equals 2x plus 1, and we're going to plug in 1 for x, 2 for x, and 3 for x. And we get 2. Let's see, we get 3, 5, 7. Now we need to take a look at what 2 points they have in common. Oops, I'm sorry, I wrote that in the wrong spot. Of course, now I have to change color. All right, 3, 5, 7 should be up here. All right, now we're looking for the one that is different, that is the same, sorry, on each one. 3, 7, 3, 7. So the solution to this systems of equations is 3, 7. Okay. Now I would pause the video and try the next 6 tables. This one, this one, this one, this one, and the last 2. So plug in your points, right? This is your input. If I input a 0 for x, if I input a 1 for x, if I input a 2, what's happening? What is the answer? 0, 6, 12. And then you do the same thing here. 0 plus 10, 1 plus 10, 2 plus 10. So you have 10, 11, 12. And you're looking for when they have the same ordered pair, and it shows up right here, 2, 12. So 2, 12 is the solution to that system. Okay, now definitely pause the video and try the last 4 tables. Okay, those have been changed to -1. Again, I'm going to input the x's. It's a negative. And see what I get from my y's. 2, -4, -6. And on the other side, put in a -1 plus 3, 2 plus 3, 3 plus 3. So we have 2, 5, and a 6. And the point that they are the same is right here, -2, 1. Sorry, -1, 2. So, and if you want, and you can see, right, when I plug in a -1 here, my answer is a 2. When I plug in a -1 over on this side, my answer is a 2. And for the very last pair of tables, the procedure remains the same. Plug in for x, and you'll get 3, 1, -1. Plug in for x, follow the orders of operations, and get your answer, which is y. And then we look where they are the same. So if you look at this, 0, 1, and 0, 1. So the solution is 0, 1. And if I were to graph these 2 lines in Desmos, they would intersect at 0, 1. Now we're going to practice putting them into Desmos and seeing where the solution is. So a systems, right, is 2 or more linear equations with the same variable. Variables, should say. And the solution is any ordered pair that is a solution to both equations. All right. As you can see, example 4 asks the question. Oops, sorry. Ask the question. Ask the question, is 416 a solution to the following systems? So these fancy brackets indicate a systems. So y equals 2x plus 8 and y equals 4x is your system. You can plug it into Desmos, like the example here, exactly like it's written, and you will see that it intersects at the point 416. So the lines intersect at 416. And if you remember from the spreadsheet yesterday, that means that when I plug in 4 for x, the answer to both of them should be 16. And it, in fact, if you follow the orders of operations, when I input a 4, it output a 16 for both equations. So that's the solution. So for the first one, you can just either bring in a screenshot or sketch what you see on Desmos. So this is asking, is the ordered pair 5, 1 a solution to these two equations? Now, if I bring this into Desmos, I have one equation running this way and one equation running this way, and the dot is at 3, -7. So because they intersect at 3, -7, 5, 1 is not a solution. All right? It is not the point of intersection. Okay, same thing for example 6. You can either bring in a screenshot or you can sketch it. And I'm going to sketch it right here. I've done both. I've brought in screenshots and sketched it. So this is going to be one line. This is going to be another. And you will see that they do, in fact, connect at -2, 8. So because they intersect at -2, 8, yes, it is a solution. And then the last one, I'll draw the coordinate system. If you graph both of them, one goes this way, and then one is this way, and you actually get some decimals for this one. It's like it connects at like 5.6 and 1.6. That's approximately. So they do not connect at 4, 2, so it is not a solution. All right. They do not intersect at the ordered pair 4, 2. Okay. Now let's see what happens when we plug in x values for this and what the output is. So for this equation right here, y equals -5 minus x. I want you to pause the video and I want you to plug in 1, 2, 3, 4, 5 for x and see what your answer is. Now feel free, you might want to get a calculator to make sure that you're not missing any negative signs, okay? But either way is fine. I'm going to do a few of them. So if I plug in 1, it's going to be -6, -7, -8, -9, -10. I don't know if you notice a pattern, but they're going down by 1, and the coefficient up here is -1. Okay, this is my input. This is my output. All right, when I input 1 into that equation, I'm going to output 0. When I input a 2, I'm going to output a -3. Okay, when I input a 3, it's going to be -6. When I input a 4, it's going to be -9. When I input a 5, it'll be -12. Now, for example 7, I've given you the graph, and I'm asking you, between the red line and the blue line, what is the solution? And the solution is the intersection point. Okay, and the intersection point is 2, 2. Okay, same thing here, right? Example 8, what is the solution to the following equations? All right, I have my red line and my blue line, and they intersect right here, which is the point 0.4 and 4.4. Okay, make that clear. That is the solution because that is where they intersect. Now we're going to go see how this fits into word problems. Okay? Example 9. To become a member at a skating rink, you have to pay a $30 membership fee and $5 every time for a skating session. For non-members, it is $7 for each skating session. At what point is it the same cost to be a member and non-member? Use Desmos to find your answer. You want to let y equal total cost and x equal the number of sessions, okay? So you want to, let's see, our membership, we're looking at a $30 initial fee or starting point and $5, all right? And it tells us that we have to use y and x. So this would be y equals 30 plus 5x. And for a non-member, it is $7. That's 7x, okay? So you want to put both these equations into Desmos, and you should go practice this. Make sure that they intersect at the point 15,105, okay? And what does that mean? 15,105 is the solution. It works in both equations, okay? But it means, so let's put 15,105 here. It means that at 15 visits, whether you're a member or a non-member, it will cost $105 to skate. Example 10, a car dealership sold 78 cars, new cars, and 108 used cars this year. The number of new cars sold by the dealership has been increasing by 6 cars each year. The number of used cars sold by the dealership has been decreasing by 4 cars each year. In how many years will the total number of used cars and new cars be the same? All right. So we want to begin with the systems where y is equal to total cars and x is equal to years. So for the new cars, the used cars, they start out with 108, okay? And the used cars has been decreasing. So it's y equals 108 minus 4x. But the new cars start out with let's see, 78, right? And it has been increasing by 6 each year. Okay, when I plug this into Desmos, right, when I put both equations into Desmos, it intersects at the point 396. So that is the solution. And I'm going to put that here. The point where they intersect, or the solution, is 396. And in terms of the cars, it means that in 3 years, there will be 96 used and new cars. Okay? Example 15 is about a Parks and Rec department offering a season pass for $90. With a pass, you pay $4 per session to use the tennis courts, and without the pass, you pay $13 per session. So y is the total cost, and x is the number of times you play tennis. So if you have a season's pass, you have to pay that initial $90, and then it's $4 every time you use the tennis courts. If you don't have a pass, so no pass, there's no initial fee and you just pay $13 every time. Now, when I'm asking you for the equation, so all of these answers should have y equals, because that makes it an equation, okay? Y equals 90 plus 4x, and y equals 13. When you put these in Desmos, okay, they intersect at the point 10, 130. That is because that is the point of intersection. So the solution is 10, 130. This is the point of intersection. Okay? That means if you play tennis 10 times, whether you're a member or non-member, it will cost 130. All right? And then the last one, actually, D asks you to get a little more detailed, okay? What exactly does this mean? Well, I always say the solution 10 is the even point, okay? When you play tennis 10 times, it costs the same. Oh, it costs, that should say, the same for members or non-members and non-members. All right, so if you're considering whether to become a member or non-member, you want to consider if you play tennis, it actually probably is 1 if you're going to play tennis, because you can't play 0 times, right? Let's make this a 1. Between 1 and 9 times, then it is cheaper without a pass. All right? If you're going to play tennis more than 10, it is cheaper to get a pass. All right, and that concludes our lesson on systems of equations and graphing. And remember that when you graph a systems of equations, the point of intersection is the solution.